All right, y'all. So 6.8 deals with increasing, decreasing, and piecewise functions. Now we've played with the increasing and decreasing. So those are pretty much like we did in 7.5. So they start out with the piecewise functions. So y'all, a piecewise function is a set of equations in which the domain determines which equation is used to find the function value. All righty, so in the real world, if you work by the hour, you probably would use piecewise functions to determine your paycheck. So if you made $10 an hour and you work up to 40 hours to figure out your pay, you would take your hours times your $10 an hour pay. But think about overtime. Overtime would use a different equation, right? You would get time and a half pay for any hours over 40. So let me show you an example here. And I'm going to assume my person makes $20 an hour. So the pay depends on the hours you work. So that'll be the T for the time. So it'll be $20 an hour times T, which is my time. I would use that equation for any time that is less than or equal to 40. Now, anything over 40, I would use this equation, 800, which would be 20 hours times, $20 times 40 hours is going to give you $800. But to figure out the overtime, time and a half for 20 would be $30 an hour. And I'll get that for my total time minus the 40 hours. So if I work 45 hours, 45 minus 40 would give me 5 hours of overtime at 30, plus the 800 I got from my 40 hours. So I would use this for any T that was greater than 40. So y'all, this is a real nice piecewise function. So when they start out, they're going to give us questions like find which equation you would use to find P of 35. Now, they don't want to know what value I would get. They just want to know which equation I would use to find P of 35. So that's what you got to look at your domain for. Is 35 less than or equal to 40, or is that 35 greater than 40? So since 35 is less than 40, we would use the first equation, which would be the 20t. All right, now I'll show you another one. Find which equation you would use to find P of 50. So if you work 50 hours that week, well, y'all, I would look at my domains again. 50 is either going to be less than or equal to 40, or it's going to be greater than 40. So this time, since 50 is greater than 40, I would use the second equation, which would be the 800 plus 30 times the t minus 40. So now at the end of the chapter, we'll actually find the values. But just starting out, they just want to know which equation you would use to find those values. So what I'm going to do is share MathLab. Well, not sharing yet. Let's do some of their examples. All righty, so given the piecewise function, identify the expression that should be used to find f of a -9. Now my function is going to be f of x equals, and y'all, this has three equations. It equals x minus 2 for any x less than -5. It equals x squared for -5 less than or equal to x less than 4. And then we're going to use the equation 8x for any x that is greater than or equal to that 4. So notice your domain is broke up. Anything less than -5, I use that first equation. If it equals -5, but less than 4, I use the second equation, x squared. And then if my x is greater than or equal to the 4, I use the 8x equation. So for f of -9, well, you got to figure out, is -9 less than -5, equal to -5, less than 4, or greater than 4? So y'all think about this. -9 is definitely left of -5 on that number line, which means -9 is less than -5. So we would use the x minus 2 equation. Y'all get an idea of these? You're going to look at that domain, then find your equation. So y'all, let's try this again. 3 more sets of equations. Identify the expression that should be used to find f of 10. So this time they're giving us f of x. And then this one's got 3 equations also. It's going to equal 3x, 4, x less than -7. It's going to equal x squared for -7 less than or equal to x, but still less than 2. And then I would use the x minus 4 equation for any x that is greater than or equal to my 2. So the question is, where does this 10 fit into my domain? It's either going to be less than -7, equal to -7, but less than 2, or it's going to be greater than or equal to my 2. So y'all, since 10 fits into the last domain, we would use the x minus 4 equation. Okay, so just remember on this part, all they want are the equations you would use, okay? All right, so then we start getting into increasing and decreasing. So to do the increasing and decreasing, I'm actually going to get into the Math Lab, okay? So I'm going to share my screen for Math Lab. Y'all, we're going to make this graph a little bigger for us. Now, I will say these 3 problems in college algebra are the same ones that you did in the support lesson for 7.5. So y'all, we know these already, so let me see what y'all think on the function is increasing, which means left to right, it's going uphill on what interval? And you got to remember one thing. We're only concerned with x values where it starts increasing and where it ends. And y'all, I'll tell you what, the left side's going downhill, then you're constant, then you're going uphill. So if we look on the x-axis, that last little section starts going uphill at 4 on the x-axis. And as I head to the right, it's going to keep going uphill. So y'all, we would actually go with, let me see what my chat's saying. Oh, okay. So the thing on this one, I got a C answer on that, but they're using a bracket on it. And see, that 4 is where it stops going from constant to increasing. So we would use curvy parentheses because that's the pretty much the changeover point. So remember, on the intervals, you're always going to use parentheses. Now, we will use the brackets later, but we're going to use those when we do the range. Okay? So that would be actually A, y'all. And then you check that. So let's see what's next. Constant. Where does it start being constant or straight across? And where does it end? And y'all let y'all light up my chat with that. All right, y'all, let's see what chat's saying. So I'm getting a C on that one, C on that one. Perfect, -4 to +4. So it starts at -4 on the x's, and as you ride all the way to +4, it's going straight across. So we would go with C. Good job. And then it's going to want decreasing. Well, that's the left side. So where's it coming in from, and where's it decreasing to? All right, y'all, there's my chat. I'm getting B on that one. Perfect. Coming in from -infinity, going to -4. Good job. So we would go with B. All right, y'all, so let me do this one and then we'll get into some other stuff they'll ask us. So notice, you got two intervals that are going uphill left to right. The second line and the fourth line. And looks like they got different values. So if we can get that first line, we should be able to get the second one with no problem. So I'm looking at the first line, and on bottom, that black dot, I'm going to go straight up and see where that's starting at on that x-axis. So y'all, that thing looks like it's starting at -5. And as I go down, -4, -3, -2, -1 is where it stops going uphill. So I know the first line is -5 to -1, which means the only answer I can go with is D, because I got another one over here. So I'm going to look at the bottom of the V where the fourth line starts going uphill. And looks like that's starting at a +5 on the x-axis. And then 6, 7, 8, 9. 9 on the x-axis is where it stops going uphill. So let's see, that would be D on that one. But what's nice, if you can get the first line, there's only one answer that has two uphills with that first one being right, okay? I'm going to check that. So, dude, this one wants me to fill it in. So, where is it decreasing? Well, that's the third line going downhill left to right. So, do y'all want to stab at that one? So, we need to know where it's starting at and where it's ending at on the x-axis. All right, I'm getting a 0 to 5, so let's see. Yeah, definitely starting on 0 because it's on the y-axis. And then that's got to be 5 because that one has to end where the other one started, Walgo. So good job, Nancy. That is definitely 0 to 5. All right, then I guess they're going to want the little constant line next. You know, the little constant line, what's the x value of the black dot? And then what's the x value of the hollow dot there? So let's see. I'm going to try to count that. That looks like the dark dot looks like -7 to me. And then the hollow dot, well, that's only 2 over. So that's got to go from what? -7, -6, -5. All right, so let me see what chat's got going on. So, Vinny, you got the numbers right, but remember, they always got to go from left to right on those, okay? So always start at the left side and then go to the right side. Good job, though. All right, y'all, so let me go back to the camera for a second and give you a few definitions, and then we'll play with the next set of exercises here. So some new terminology here will be what we call a relative maximum and a relative minimum. A relative maximum. Now, this ain't the overall maximum of the graph. When we talk about a relative maximum, we're talking about peaks that occur in the graph. So these are peaks that occur in the graph. Okay, so I'm looking at like mountaintops on those. And then the relative minimums. Well, y'all, those are going to be valleys that occur in the graph. Okay, so my peaks, we're looking at little mountaintops, and for my minimums or my valleys, I'm looking for minimums. Okay, so we'll go back to the graph for these. So let me just show you an example here. So if I had a graph that went uphill and then came downhill and say it went up again, this one would have a relative max right here. But right here, it would have a relative minimum. But I want you to see the relative max, although it's the maximum on this little peak, this graph is going uphill forever. So it's not the overall maximum, but it is the maximum value relative to this area, okay? So let's go look at these examples. So I'm going to share this back to the math lab. And these start at 7 here. And y'all gonna make her little graph bigger. Now they're telling me the point of that. Remember, that's like the vertex. That point is 4.5 and 5.25. So does it have a relative max or minimum? Well, it's a mountain top, so that would be a relative maximum. So we would click that, check that answer. Now, here's where it gets tricky. The relative maximum occurs at what x value? Well, y'all, that'll be the point they're giving me. The x value is what? 4.5. So you would put in your 4.5. And it has a maximum value of, well, remember, the max values are equal to the y values. And that is, oh, let me look. That looks like 5.25. Okay, so they want to know where it occurs at and its value. So we would check that. Then they want to know the increasing. Well, this is increasing on the left side. Remember, they're going uphill on the left side of that graph. So A, B, C, or D on that, y'all. All right, chat, let's see what y'all were saying. So I'm getting a C on that. Let's see. C definitely, because you're coming in from negative infinity and you're increasing till you get to that x value of that maximum, which is 4.5. So good job, y'all. That'd definitely be C. And I bet they want that decreasing next, right? So decreasing starts at the x value of that maximum and it heads towards what? Cat, y'all are quick today, so I'm getting an A on that one. So let's see, starting at 4.5, definitely going to infinity. So everybody's saying A, good job, y'all, definitely A. So good job, y'all didn't focus on those Y values. They're throwing that 5.25 in there to mess with you. Okay, we don't care about the amounts, we got to stay on the X's on those. All right, y'all, let me make this one a little bigger. Notice this one has a max and a minimum. So first of all, they want to know the relative maximum. That's going to be the little hump. The first little hump on the left side, -6, -1. But notice this one. This one's backwards. They want the value first and then the x equals. So the value is going to be the -1. And that happened at the x value of -6. Okay, so they try to get tricky on Math Lab, switching the order up on these, so watch out for them. All right, so we're going to put answer on that one. So y'all, this is the relative minimum. What would y'all put in this one? The relative minimum is blank, at x equals blank. All right, woo, chat's quick. So there you go, negative 19, perfect, y'all. And then I'm getting 0, good job. So negative 19 for the value, and that happened at the x equals 0. All right, let's see what they want next. So, they're going to want increasing and decreasing. So remember, this is increasing in 2 spots. The first section and the third section are both going uphill. And remember, these definitely start at negative infinity on that left side. And cruising till we hit that x value of that peak is what, a negative 6. So looks like A and B are in the running so far. So let's see what chat's saying. You're going with A on that. Definitely, because the second part starts at 0 going uphill to infinity. Good job. So that one you actually had to find them both, since 2 answers both had that negative infinity, negative 6 on it, okay? Now you know what's next. They're going to want that middle section going downhill. So going downhill, A, B, C, D. B, so let me see what is B saying here. So everybody looks like they're starting to say B. Yeah, because it starts at the negative 6 at the peak, and it's going to 0 where the valley started, right? Or the minimum value. So definitely negative 6 is 0. So good job, y'all. So there's only one more of these. Let's play with it. But look, this one, they're giving you choices for the minimum and maximum. So the maximum, that little hump, is that maximum a 1 at x equals 0? None they got. Is it negative 3 at x equals 2? Or is it 1 at x equals 0? And then the relative minimum, the little valley there, is it negative 3 at x equals 2? So A and B both say negative 3 at x equals 2. And then I got a 1 at x equals 0, and then a none. So chat, let's see what y'all got. So I'm getting A on that. So let's see, Biddy, let's see what you got. So the first one is definitely a 1 at x equals 0. In the second one, it looks like negative 3 at 2. So good job. Definitely A. And then we could automatically eliminate B and D with that none stuff, because we do have one of each on that, okay? Oh, y'all, that's all we had to do on that, and so good job. So now let me take us back. We're going to get into the piecewise functions. So y'all, let me write this one down. We got g of x equals x plus 7 for any x less than or equal to 2. Then it equals 8 minus x for any x's greater than 2. Now notice what they want me to find. G of negative 8, G of 2, and G of 3. All right, y'all, so I got that written down. Let's go work that out. And y'all realize we're going to find 3 different values with these numbers here. So let's start with G of negative 8. First of all, I got to figure out which domain that negative 8 fits in. Once I know the domain, I'll know which equation to plug my negative 8 into. So negative 8 is either going to be less than or equal to 2, or it's going to be greater than 2. Well, it's definitely less than 2, so we would use the first equation, and in place of the x, we put our negative 8. So we get -8 plus 7. And then we work that out. So -8 and 7 gives me a -1. So y'all, let's see. G of 2. So y'all, that one's going to be on y'all. Would y'all use the first equation or the second equation? And then what value would you get out of that? And I'll give y'all a second so my chatters can write all that. So they try to mess with y'all with numbers that are on the turnover point. So I'm getting the first, and would it be 9? So let's see. So G of 2 is definitely equal to 2. So I'm going to use the first one, and good job. You're going to put a 2 in for this x, and 2 plus 7 does equal 9. Good job. And then y'all, try my G of 3 for me. All right, chap. Ooh, y'all rolling them in today. All right, I'm getting second equation in 5. Okay, good job, 5, because look here, G of 3. Well, 3 is not less than or equal to 2, so we can't use the first equation. So you put 3 in for the x on the second one because 3 is greater than 2. So good job, y'all. Since it's greater than 2, I'm using the last equation. And that'll be 8 minus my 3, which would give us a 5. So remember, this at the end, the 4 part, is just for you to figure out which domain you fit in, and then you grab your equation. So y'all, let's go put that in, and then we'll see what they got coming up next. All right, so G of -8, we got -1. And I guess it makes you check each answer. G of 2, y'all said 9. And then G of 3, y'all said 5. All right, so we got everything in. So let's look at this last one here now. Woo, big equation, y'all. Look here, we're going to find. So h of x is 3 equations. -5x minus 14. And I'm going to use that for any x that is less than -8. It equals 4. 4, -8 less than or equal to x less than +4. And then it equals x plus 1 for any x that is greater than or equal to 4. Now, y'all, they want what? H of -10, H of 3, H of 4, and H of 7. All right, so let's go back, work that, and then we'll put those numbers in. Well, I might not put them in because this, I think, is the last question. Yeah. So let's go play with that and see what we get. So I'm going to start with H of -10. So I'm starting with my first domain. Is -10 less than -8? That is true. Remember, any number to the left is smaller than another number. So if you're looking at your number line, you know, going left to right, Any number to the left of another number is less than that number. So you got -8 and then -10. So -10 is less than -8. We're going to use the first equation. So -5 times our -10 minus 14. All right, y'all, negative times negative, that's a positive 50 minus our 14. And let's see, 50 minus 14 gives us, what's that, like 36? So h of -10 is 36. H of 3. So first of all, y'all tell me for h of 3, would I use the first equation, second equation, or the third equation? Is 3 less than -8? Is it equal to -8, less than 4, or is it greater than or equal to 4? So first, second, or third equation? All right, Chad, I'm getting, let's see, third equation, let's see. All righty, so I'm getting a 2 on one and a 3 on another. So think about it, y'all. I'm looking at 3. 3 is not greater than or equal to 4, so I can't use that third equation. If you put a 3 in for that x in the middle, it's greater than a -8, but 3 is less than that 4. So you got to use the second equation. But y'all look, the second equation tells me for any numbers in between here, it automatically equals 4. So that'd be like a little constant section. Everything between -8 and 4 equals 4 on that one, okay? So how about h of 4? Is h of 4 using the first equation, second equation, or the last equation? And really, it's between these bottom two, okay? So is your x less than 4, or is it greater than or equal? So I'm getting x plus 1, good job. Definitely the x plus 1. Because of that equals on that. So the third one. So y'all, on that one, we got to put our 4 in for the x. So we get 4 plus 1, which will give us a 5. And y'all, finally, was h of 7. So what I want y'all to give me this time, not which equation I would use, tell me what my final value would be. Oh, that was pretty quick. I'm getting a 8 on that. And so let's see. So it looks like you're using a third equation and put a 7 in for the x. So that'll be a good job. 7 plus 1, which is definitely going to give us an 8. So you would plug them back in. So it makes us do them one at a time. So we got 36 right there. We got a 4 on that one. So anything on that second equation equals 4. Then y'all got me a 5. And then finally, we got the 8. Now, y'all listen, they're going to use all 3 of those equations, and one of them's going to get used twice because you had 4 values, okay? But y'all, that's the trick on those, is to figure out where your domain is and then find that value. So let me get my paper turned over. It starts folding up on me. All right, so now we're going to knock out 5.4. So the last section for test 2. Now, 5.4 deals with what we call complex rational expressions. So pretty much fractions. When you see rational expressions, you know you're dealing with a fraction. But y'all, listen, we're only going to play with one formula in this section. And this is what we call the difference quotient. And this difference quotient is basically a slope formula. But I can use this slope formula for curvy lines, straight lines, and all that fun stuff, okay? Now, the actual formula for the difference quotient is f of x plus h minus f of x all over h. So basically, I'm not going to get real deep into it, but say I had a curvy line and I wanted to find the slope at these points. This would be the slope of this line, and we call that a tangent line off these points, because each of these parts of this curve are going to have a different slope. Like over here, this slope will sort of be like that with a tangent line. So when you got curvy lines, the slope is different at different parts of it. So we use this, this is like your y2 minus y1 stuff all over the h. H would be the difference between the 2 points. Now, I'm not going to get real deep into this, but if you take calculus or business calculus type classes, they will really get deep into explaining about these tangent lines, okay? So we just got to know how to evaluate this. So the steps to construct and simplify the difference quotient. So these are the steps we're going to use to simplify this thing. Now, they're going to give you f of x, and that h is always on the bottom. So the first thing we got to do is find f of x plus h. So now, once we find what f of x plus h equals, we're going to plug it in, plug f of x in, and then remember, the bottom is always a h. So the second step, plug everything into the formula. All right, so I'm going to have my f of x plus h stuff minus my f of x stuff all over h. At that point, I'm going to combine like terms on top. After dropping the parentheses, and distributing the subtraction. Now check this out. At this point, when I combine these like terms, all terms without an h will cancel out. So after you combine them like terms, if you got stuff that don't have an h in it, something went wrong, because everything that does not have an h is going to cancel out at that point. So I'm going to have all this h stuff on top over the h on the bottom. So the last step on this, we're going to simplify the result by dividing all terms on top by the h on the bottom. Okay, so if you got 3 parts, everybody's going to divide by that h. 2 parts, everybody's going to divide by that h, okay? All right, y'all, so these are not bad if you can figure out that f of x plus h. That's the hardest part to me, is getting that. Once we got f of x plus h, we're just plugging stuff in and simplifying and all that fun stuff, okay? So let's start with our first one. So 4 f of x equals 6x minus 4. We're going to construct and simplify our difference quotient, which is f of x plus h minus f of x all over h. So we know f of x. When we put that in, that'll be the 6x minus 4. So let's find f of x plus h. So to find f of x plus h, we take the f of x function and put an x plus h in for the x. So y'all, that'll be 6 times x plus h minus 4. So it looks like f of x, but we've now got an x plus h there. So to simplify this, I'm going to distribute my 6 and get rid of these parentheses. So 6 times x is 6x. 6 times h gives us a 6h. And then we have our minus 4. Now y'all notice this. We cannot simplify this any further. I do not have any like terms. So at that point, I know I've got my f of x plus h. So now I'm going to plug these into the formula. Now I always start out with parentheses because you're dealing with different polynomials here. So f of x plus h minus my f of x will be all over h. So let's plug in f of x plus h, which is 6x plus 6h minus 4. F of x goes here, which is the 6x minus 4. All right, y'all, then I said the next step would be combine like terms on top after dropping the parentheses and distributing the subtraction. So I'm going to drop the first parentheses. I get 6x plus 6h minus 4. Now here I will distribute that negative. So a negative times a positive gives me a negative 6x. And a negative times a negative makes that a positive 4 all over RH. Now, you all watch this. Everything in the second parentheses always cancels out with its counterpart in the first. So this negative 6x here, it's going to cancel with that positive 6x. This positive 4 here will cancel with the negative 4. Now notice we said right here, all terms without an h will cancel out. Well, look, Everything's gone that didn't have an H. All that's left is the H stuff. So I got a 6H over H. And y'all, my last step. Divide all terms on top by the H on the bottom. Well, y'all, if you divide the top by the bottom, guess what? These H's cancel out, and my final answer is a positive 6. Which, if you know anything about that y equals mx plus b stuff, m is the slope. Well, when it's a straight line like this, 6 is the slope. And look at my answer, 6. Because remember, the difference quotient ain't nothing but a fancy slope formula. So if you just got a straight line, it's pretty much going to equal whatever number's in front of the x. But y'all, college algebra, we deal with curvy lines in here. So let's go play with some more of these, but let's start with some squares, okay? All right, y'all, so for this next example, they're giving us f of x equals x squared plus 3. So we're going to construct and simplify again. Or f of x plus h minus f of x all over h. Now, they will give you the formula every time on this, okay? So I've got f of x already. I've got h already. We got to find f of x plus h. So y'all put the x plus h in place of the x. You're going to have a x plus h squared. And then at the end is a plus 3. So we're squaring x plus h. So I'm going to do that on the side over here. Now, whatever we get for this x plus h squared, I would save that, because every time you get this, you're going to replace it with what we get out of this, okay? So save this for your homework, quiz, test, and everything. So the proper way to do that is to write it twice and FOIL. And y'all, I think a little bit later on, we'll have a cube over here, so that'll be even funner. So what we get here, I want y'all to save it for y'all's. So x times x is x squared. X times h is a hx. Starting on the inside, h times x is another hx. And then finally, h times h is h squared. I'm going to add the like terms, so I get my x squared. 1 plus 1 gives me 2hx plus h squared. So y'all save that right there, because anytime you get an x plus h squared, you're going to replace it with that. So that gives me a x squared plus 2hx plus h squared, and then my plus 3. Y'all look at that. No like terms. So that's as far as we can go with f of x plus h. So now we're ready to plug everything into that formula. So I'm going to plug everything into my formula. So f of x plus h minus f of x will all be over RH. All right, y'all, so let me plug in x squared plus 2hx plus h squared plus 3. F of x was the x squared plus 3 up here. And then my h on the bottom. All right, so now what I want to do, distribute my negative over here and drop all my parentheses. So the first one comes out, x squared plus 2hx plus h squared plus 3 minus x squared minus my 3 all over h. So y'all, if you notice, everything's canceling again from the second parentheses. Negative x squared and x squared, negative 3 and a 3. All that's left are the h things. So my thing is, if you can figure out the f of x plus h stuff and get rid of the stuff that don't have h's, you can eliminate a whole lot of writing on these, okay? Because look, all that's going to be left is my 2hx plus my h squared all over h. Now, you got to simplify this. So what I want you to treat it like 2hx over h plus h squared over h. This is what I mean by everything on top is going to get divided by the h on the bottom. So look here, the first part, 2hx over h. Those h's cancel. All that's left is 2x. And that'll be plus. So right here, you got an h squared over h. Subtract exponents. 2 minus 1 leaves me 1h. And we're done. So remember, one of these h's cancels with one on the bottom, leaving 1h. And y'all, that right there would be my final answer. So they're not too bad if you get the f of x plus h. And I mean, even at that point, I could have took out 1h here and had 2x, 1h here and had my h. So I'm doing a lot of writing, but you can do them in a lot less writing if you are seeing what we're doing here, okay? Woo, y'all, I got a good one coming up, so let's see. We're about to play with a good one. So let me let y'all write that one down real quick. All right, y'all, so moving on to a good one here. All right, y'all, so this time we're giving us f of x equals negative 2x squared plus 3x plus 1. We're going to construct and simplify. Or f of x plus h minus f of x, all of that, over h. So we got a good one here because I got two x's. So when we find this f of x plus h, you've got to put the x plus h in for both of these x's. So you're going to have negative 2 times x plus h squared plus 3 times x plus h, and then plus 1. Notice it still looks like f of x, negative 2 times your x squared plus 3 times your x plus 1. Now, I'm going to bring down that negative 2. Now, we already know what x plus h squared equals because we worked that on the last problem. X plus h squared equaled x squared plus 2hx plus h squared. And then I'm bringing everything else down. 3 times my x plus h plus my 1. Now, all I do on my first step is square this stuff. Now, I'll distribute my 2 through the first parentheses and my 3 through the second parentheses and bring down to 1. So distributing the 2, I get negative 2x squared. Negative 2 times 2 gives me a negative 4hx. Negative 2 times h squared is a negative 2h squared. Now I distribute my 3. 3 times x is 3x. 3 times h is 3h. And then at the end, I bring down my plus 1. Now y'all look at this one. There's no like terms here. No like terms at all. So all of this is the f of x plus h. So it's got 1, 2, 3, 4, 6 terms in it, okay? All right, so guess what? Plug into the formula. So I got my f of x plus h, which is negative 2x squared minus 4hx minus 2h squared, plus a 3x plus a 3h plus 1 minus my f of x, which is this right here, negative 2x squared plus my 3x plus 1, all of that over h. Now, at this point, we realize that these three are going to cancel with their counterpart over here. So remember, negative times a negative makes that a positive 2x. It'll cancel with that negative. So those are gone. The 3x is really negative. It'll cancel with the positive 3x. And then the 1 is really negative. It'll cancel with the positive 1. So save yourself some writing. And remember, all these will cancel every time from the second parentheses. So y'all, let's see. I got 1h here, h squared here, and an h. So I got 3 things left. Negative 4hx minus 2h squared plus my 3h are all over h. So I'm going to let y'all take a stab at simplifying that. Y'all simplify that for me and chat me up and see what y'all get. All right, y'all, I'm seeing some chats coming in, so let's see what y'all say. So negative 4x, good, because the h's are going to cancel on the first one, so you're left with negative 4x. In the middle, the negative 2 comes down, and then you had an h squared over h, which left me 1h. Good job, y'all. And then plus my 3. Those h's would cancel. So, boy, y'all both are right. Good job on that. So, that would be our final answer. And y'all remember, it's like splitting this one into 3 fractions and canceling everybody by that h right there, okay? All right, so we got through the squared stuff. So we got one more problem here. And they're going to want a cube on this one. So there's only 5 of these on the homework, and that's because, woo, they're sort of long to figure out a little bit. So y'all, we got f of x equals, oh, what I got there? 3x to the third. So finally, we're going to construct and simplify again. F of x plus h minus f of x, all of that over RH. All right, y'all. Y'all know this is about to be a fun one because f of x plus h is going to equal 3 times x plus h to the third. So let's figure out what this equals on the side over here. Now remember, whatever we get for this, y'all need to save it because y'all are going to need this for homework, quiz, and test. But x plus h to the third is x plus h times x plus h times x plus h. But y'all agree, we know what 2 of these equal, don't we? So let's bring down this x plus h in the front. We multiplied 2 of these a while ago, and we got an x squared plus 2hx plus h squared. All we got to do now is figure out what this x plus h times all this will give us. So I'm going to distribute the x first. X times x squared is the x cubed. X times 2hx is a 2hx squared. So I'm basically adding the x to everybody. X times h squared is a h squared x. And I really try to keep these in alphabetical order to keep up with stuff. Now I'm adding the h to everybody by distributing this h. H times x squared is a hx squared. H times 2hx is a 2h squared x. And then h times h squared is a h to the third. Now, y'all, you do have like terms in here. So bring down that x to the third. These 2hx squareds will add to 1hx squared. So the exponents got to match and the variables. So 2 plus 1 gives me 3hx squareds. Now this 1h squared x will add to these 2h squared x's, giving me 3h squared x. So that takes care of those like terms. And at the end is my h to the third. Y'all, save that, because anytime you get an h plus x plus h to the third, you're replacing it with that. So I got 3 times x to the third plus 3 hx squared plus 3h squared x plus h to the third. Alrighty, so we've plugged in for our x plus h to the third. Now we got to distribute our 3, and then we'll be done with the f of x plus h. So 3 times x cubed is 3x cubed. 3 times 3 is 9. H x squared. 3 times 3 is 9h squared x. And then 3 times h cubed is a 3h cubed. Whoo, that's a lot of fun right here, y'all. But y'all, guess what? For test 3 material, we're going to be doing a lot of these cubes and fun stuff like that, okay? But y'all, no more like terms here. So all of this is now f of x plus h. So let's plug into the formula. So f of x plus h, 3x cubed plus 9hx squared plus 9h squared x plus 3h to the third minus f of x. Well, the only thing I got is a 3x to the third. All of that over h. So sadly, only one thing's canceling because there's only one thing over here that does not have that h in it. So the 3x to the cube is minus. It's going to cancel with the 3x to the cube. So y'all, let's see what we got left. A 9hx squared plus a 9h squared x plus my 3h to the third all over h. Now, the trick on these like terms and all this is to keep up with these exponents on these variables, okay? All right, y'all, so let's see. The first one cancels by canceling the h's. So if that h cancels, all that's left is a 9x squared. In the middle, one h cancels, leaving me a 9hx. So notice 1h canceled in the middle, plus, on the end you got 3 h's. One's going to cancel. So let me see what chat's saying. Okay, so I was wondering how y'all's going to write those exponents. So let's see. We got a 9x squared perfect, 9hx, and girl, that's perfect because I get a 3h squared at the end. All right, so Vinny, you definitely ready for these things. And y'all, guess what? That right there is your final answer. So woo, be careful with them and keep up with the exponents. But y'all, I wouldn't fold this out. I would keep these numbers right here. And then I would keep the ones we did for the squared while ago, because y'all are going to need those when y'all do these. And then I would keep notes of those and save them for when I did my test and my review, okay? So y'all, let's see. What was today? Tuesday? So Thursday, we're going to come in and review for test 2. And you'll notice I extended the due date for test 2. Test 2 is going to be due by March 24th. So I'm giving you all through spring break to play with that one, okay? And see what y'all do with that. So yeah, next class we're going to review for test 2. And then I'll give y'all the ones I'm going to have y'all do for work. I only picked 4 on this one for work, so it's not as bad, okay? All right, let me see. That was what, 6, 8, 5, 4. All right, y'all. So, any questions?
So next class, we're going over the test.
We're going over the test.
Okay.
And now the reviews are open and stuff, and it's only 20 questions. But we will definitely do all 20 of those on Thursday night. And then we won't start the next material probably until after spring break. So y'all remember next week is spring break. Okay. And then another thing I want y'all to think about, once y'all get back from spring break, it's going to be time for y'all to, I think April, might be April 7th, but y'all going to be able to start picking your classes for the summer and the fall, starting around April 7th, I think. And once y'all got this college algebra out of the way, you can start taking all them sciences and all that fun stuff, okay? All right, I'm gonna quit my recording so it won't take forever to download later.